Andrew and Kent do desktop publishing. Kent can prepare a certain prospectus 2 hours faster than Andrew. If they work together, they can do the entire prospectus in 5 hours. How long will it take each of them working alone to prepare the prospectus? Round answers to the nearest tenth of an hour. We'll first want to define variables for the unknowns. We'll let x equal the number of hours that it takes Andrew working alone to prepare the prospectus. We're told that Kent can prepare the prospectus 2 hours faster than Andrew. Therefore, x minus 2 will be equal to the number of hours that it takes Kent to complete the prospectus. Now we'll organize the information that we have in a table. We have information for Andrew, and we have information for Kent. We'll be interested in the rate for each of them, the time that they'll spend working, so time working together, and the fractional part of the job that they each complete. So fractional part of the job done. Since it takes Andrew x hours to complete the job, his rate is 1 over x. Since it takes Kent x minus 2 hours, his rate is 1 over x minus 2. The time working together is 5 hours because we're told that they can complete the job working together in 5 hours. The fractional part of the job done is the product of the rate times the time. So for Andrew, this is 5 over x, and for Kent, this is 5 over x minus 2. Now we can use this information to write an equation that we can solve for x. If Andrew completes 5 over x of the job and Kent completes 5 over x minus 2 of the job, and they complete the whole job, then we know that 5 over x plus 5 over x minus 2 is equal to 1. We're ready to solve our equation. To solve, we'll multiply both sides by the least common denominator, x times x minus 2. So we have x times x minus 2 times 5 over x plus 5 over x minus 2 is equal to 1 times x minus 2. On the left side, we use the distributive property, and we are left with 5 times x minus 2 plus 5x. And on the right side, we have x times x minus 2. Simplifying, we again use the distributive property. We have 5x minus 10 plus 5x is equal to x squared minus 2x. Combining like terms on the left side, we have 10x minus 10 is equal to x squared minus 2x. Writing the equation in standard form by subtracting 10x and adding 10 to both sides, and then switching the sides of the equation, we have x squared minus 12x plus 10 is equal to 0. Since we can't factor the trinomial, we'll use the quadratic formula to solve. In this case, a is 1, b is negative 12, and c is 10. So we have x is equal to negative of negative 12 plus or minus the square root of negative 12 squared minus 4 times 1 times 10, all divided by 2 times 1. Simplifying, we have x is equal to 12 plus or minus the square root of 144 minus 40, all divided by 2. Simplifying the radicand, we have x is equal to 12 plus or minus the square root of 104, all divided by 2. Thus, we have two solutions. X equals 12 minus the square root of 104 divided by 2, which is approximately equal to 0.9. And we have x is equal to 12 plus the square root of 104, all divided by 2, which is approximately equal to 11.1. Recall what x represents. X is the number of hours that it takes Andrew in order to complete the job when working alone. We also know that Kent takes 2 hours less. If Andrew takes 0.9 hours, then Andrew would take a negative amount of time, and therefore the solution of 0.9 is not a solution. If Andrew takes 11.1 hours when working alone, then Kent will take 2 hours less, or 9.1 hours when working alone. And this solution does check.